We are graphing general rational functions today. The horizontal asymptote occurs in a couple of different cases, and it depends on the numerator and denominator. So a lot of times the horizontal asymptote, my pen would work, that would be great. The horizontal asymptote is y equals 0 many times. But if you see something where you have like x squared over 2x squared, where you have x's top and bottom, then your rational fractional function kind of reduces. What would this turn into? What happens to those x squareds? They cancel out, leaving behind a 1/2. Okay? So that horizontal asymptote has lots of different cases, but typically it's either going to be y equals 0, or maybe you can reduce it and clean it up. Yes? We what? No, these are different. Yeah. We did simple rational functions on Friday. You know what? I put this one up on accident, and then I was like, "Oh, this is next week." Yeah. So last Friday was simple rational functions, very similar but slightly different. Today we're throwing in zeros as well. Vertical asymptotes. Where do vertical asymptotes come from? Denominator. The denominator. Vertical asymptotes come from the denominator. Zeros are also known as x-intercepts, and it turns out that they're actually going to come from the numerator for us, which is really quite nice. So we'll see that come into effect, and these are all good things to write down, ladies and gentlemen. I'm writing it down. You should be as well, okay? So horizontal asymptote, we've got a couple of different cases. It's either y equals 0, or maybe you can reduce. Possibly. Vertical asymptote comes from the denominator, and zeros turn out that they come from the numerator. So pretty cool here. We're going to keep expanding. Example 1. Factor, then graph and identify the information. Example 1, factor. Still factoring these days. Which is a general rule of thumb. Anytime you can see something that factors, factor it. Double bubble, if you can. So we have 1 over x squared minus 4. And I can see that this denominator double bubbles. And so we want to double bubble that. What times what is x squared? X times x. And what times what is negative 4? Negative 2, positive 2. Thank you. Negative 2 and a positive 2. Okay. Now, when we try to figure out the horizontal asymptote, it comes from whether or not we can reduce the leading term on the bottom and the leading term on the top. I can't clean up 1 over x squared at all. It doesn't reduce. It's totally weird. That is the case where y equals 0. We have a constant on top. I can't use long division. Okay, it doesn't simplify at all. Vertical asymptotes come from the denominator. And you might want to write that down. They come from the denominator, and we see we've got 2 bubbles, so all I have to do is set each bubble equal to 0 and solve for x. To solve for x first, I'm going to add 2. I get x equals 2 as a vertical asymptote, and I'm going to subtract 2 and I see that I get x equals -2. They come right from those denominators. Very easy to get those vertical asymptotes. These are the three really important features, really important features that we're going to start graphing with. Make a little sketch. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. I have a horizontal asymptote at y equals 0. That's our equation for the x-axis here. That's that line, y equals 0. X equals 2. I go to 2 on the x-axis and I draw a vertical line. That's my vertical asymptote. And I go to -2 on the x-axis and draw a vertical line, my vertical asymptote. This is kind of interesting. X equals -2. We have two vertical asymptotes in this case. Just like on Friday, we need a couple of other points to see what's going on, and then we're going to use our calculator. These are more complicated functions. They do funny stuff in the middle. You're going to see L's on the outer regions, but they're going to be weird stuff happening in the middle. And what we're going to do then is we're going to choose x values on the left and the right of each vertical asymptote. What is to the left of -2? -3. And what's to the right? -1. Oh my God, it's so loud, you guys. Can you hear me okay? Mostly? Yeah? Okay. And then I'm going to go to my other vertical asymptote and also choose an x value to the left and to the right. What's to the left? 1, and to the right? 3. So we're going to use 1 and 3. And I put 5 boxes, but this is good. I don't need this one. And the easiest thing to do is use our calculators and the trace function. So let's go ahead and grab our calculators and type in your equation. I don't know where my other calculator went. Ah, there it is. Okay. So we're going to use our calculators. Remember, when you're plugging in a fraction, you need parentheses. When you have more than one term, you have a single one, that's fine. But here we have two terms, you need parentheses around that. So go to y equals or go to your graphing menu. Delete, yes. Clear. Okay. Everything is cleared out, and we're going to type in 1 divided by the parentheses, the quantity of x squared minus 4. Close the parentheses. X squared minus 4. Close the parentheses. Ladies and gentlemen, please let me know if something doesn't seem to be working right, okay? You can go ahead and then press graph or draw. And you can see this is a funky picture. And you kind of have to understand that it's sort of connecting what should be vertical asymptotes here. I think I'm going to try to zoom in a little bit. Okay. So you can see these are vertical asymptotes. They are not solid lines. They are not really there. And you can see on this graph, we've clearly got some vertical asymptotes you can pay attention to there. What we want to do is figure out our corresponding y values. How do we do that? Trace. The lovely trace button. So we have a trace button. So click trace, and then all you have to do is type in -3 and hit enter. And we get 0.2. And I can do the same thing on my Casio. Shift F1 is trace, and I can type in -1 and hit enter. And I see I get 0.3333333. I can type in 1 and hit enter, and I get -0.333. And I can type in 3 and hit enter, and I get 0.2. So we can use that trace button really easily, and then we can plot these points. Negative 3, 0.2 is up just a tiny, tiny bit, and that gets our little L shape there. We have negative 1 up a third, just a tiny bit, and we have positive 1 down a third, just a tiny bit. And that's kind of, was that right? That wasn't right, was it? That seems weird because I don't have that reflected in my graph. Negative 1. Oh, it was, I missed the negative there. Look at that. Should have been negative 0.33333. So that was wrong. There we go. And so we get what is sort of like a parabola shape in the middle here. And then we have 0.3 and up 2/10, which is just up a teeny tiny bit, and that's our other sort of L shape in our little bounded region, boundary lines. So for all of these graphs, you really need your calculator to sort of help you out. You could just plug in numbers. You plug in negative 3 and you'll get the same answer out if you do it right. But your graphing calculator really, really helps. And plus, it's going to do weird stuff here in the middle. All right, you'll also notice these L's are symmetrical. It's like a mirror image on the left and the right. Okay, that's the symmetry of this graph. Kind of interesting. Questions on this one? Okay. Try another. F of x equals negative 2 over x squared plus 2x minus 3. Again, I see that I have a denominator that I can factor. And I only have a constant number on top. And that tells me something about my asymptote here. I'm going to go ahead and double bubble that denominator. X times x is x squared. What times what is negative 3? Positive 3 and a negative 1 is how we get that positive 2. Very good. What's our horizontal asymptote? Y equals 0. Yep. We don't have those matching x's on top and bottom where we could reduce them. We can't reduce a constant. That's like a fraction 1/3. It doesn't go any further. Okay. So it divides 0 times is how that works. The vertical asymptote, where does the vertical asymptotes come from? Denominator, very good. And so all we have to do is take our denominator bubbles and solve for x, which means we get x equals negative 3 for one of the vertical asymptotes and x equals positive 1 for the other. And you can jump right there. You don't have to do the work. So let's go ahead and get our graph set up here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I have y equals 0, which is right along the x-axis for my horizontal asymptote. X equals negative 3. Vertical line at x equals negative 3. And a vertical line at x equals 1. How do we pick values for x? Left and right of each vertical asymptote. What's to the left of negative 3? Negative 4. And what's to the right? Negative 2. Negative 4 and negative 2 are super awesome choices. We go to our other asymptote here at 1. What's to the left? 0. What's to the right? 2. So 0 and 2 are excellent choices there. You don't need a fifth, although you can always choose another point if you wanted to. Let's go ahead and go to our calculators and use the trace menu again. So make sure you're using a negative here for the -2. Make sure you use that negative at the bottom. -2 divided by, and whoops. Make sure you put parentheses around that whole denominator. You'll notice I'm using the original function that doesn't have any mistakes in it. Whoops. Unless I type it in wrong. Oh, which I totally did twice. Okay. X squared plus 2x minus 3, and it's in parentheses. Make sure you have it in parentheses. And then we can graph it. And you can see this time it's got L's on the bottom and a U in the middle pointing upward. So that's kind of useful. And again, we're going to use trace to figure out some corresponding values easily. So trace, and I'm going to type in -4. I get -0.4. -2, I get 0.666. Ooh, 0. I get 0.666. And 2, I get -0.4. All right. Does anyone have any questions about using their calculator? Again, you need to practice. All right, we've got -4 and -0.4 is just below a little bit. -0.2 up 2/3 between 0 and 1. 0 up 2/3 between 0 and 1 there. And then at 2 we have -0.4. And so again, we'll just draw in those little L shapes. A U shape in the middle, and an L shape on the right side. Questions on this one? All right. Last one. This one's a little different. Example 2, find the horizontal asymptote. Factor to find the vertical asymptote and the zeros. You'll notice I said find the horizontal asymptote first. What's different about this problem? You can factor top and bottom. Not only that, we have, look at those, we've got an x squared on top and an x squared on bottom. This is a function that we could use long division to rewrite it. We could use long division to simplify, but we're gonna take a shortcut, okay? So this is something that we can reduce, and that's why I say find the horizontal asymptote first. So when those match top and bottom, we just get to reduce. Then graph the rational function. So you'll notice we have 2x squared minus 8 over x squared plus 2x minus 3. We've got x's top and bottom here. And when you see that we've got x's top and bottom, we could clean it up. We could do some long division to simplify this. But the easy thing to do is look at those leading terms, the 2x squared over x squared, and reduce it. How does that reduce? Just to 2, yeah. The x squared on top and the x squared on bottom reduce, leaving y equals 2 for our horizontal asymptote. If we did long division, we'd have a 2 up there, the quotient, that we'd multiply and subtract just like we did on Friday. But we don't need to. So we found that horizontal asymptote, and now what we're going to do is try to factor. Now remember, to factor, we have a greatest common factor, and then we can see if we can double bubble. What should we do in the numerator? Divide by 2. We have a greatest common factor of 2. We need to take out that 2. When I take a 2 off of both of these terms, what's left behind? X squared minus 4. Very good. 2 times the negative 4 is how that negative 8 is there. So that one had a GCF first, and then we can double bubble the leftovers here. X times X is X squared. What times what is negative 4? Positive 2 and negative 2. Very good. Our denominator does not have a GCF, so we go straight to double bubble. X times X is X squared. What times what is negative 3? Negative 1 and positive 3. Very good. That will get us that positive 2 result we're looking for. Okay. And now when we look at this, it actually turns out to be very easy here. The denominator gives us vertical asymptotes. These numerators give us the zeros. When there is an X upstairs, it gives us the zeros. So, write those in. That's very useful. What are our vertical asymptote equations? We're going to set each bubble equal to 0. X minus 1 equals 0. X plus 3. We get X equals positive 1 and X equals negative 3 for the vertical asymptotes. And the zeros come from just setting that numerator equal to 0. The numerator gets set equal to 0, and then we set each part equal to 0 and solve. Same thing. Can I set 2 equal to 0? Does 2 equal 0? No. We get to ignore that. We can't solve for X. There's no X to solve for there. Okay? 2 does not equal 0. But X plus 2 could equal 0, and X minus 2 could equal 0. And so we get X equals negative 2 and X equals positive 2. Now, these are actual zeros, which means they're X intercepts. That's just another name for it. It means the X value is negative 2 when the Y value is 0. They are giving us ordered pairs in this case. All right, we found all the pertinent information, and then we're going to go ahead and graph what we can. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. I have a horizontal asymptote at y equals 2. So I draw my horizontal line through 2, y equals 2. I have a vertical asymptote at x equals 1. And a vertical asymptote at x equals negative 3. I'm going to choose my x values by going to the left and to the right. To the left of negative 3 is negative 4. To the right of negative 3 is negative 2. And again, to the left of 1 is 0, and to the right is 2. But look, we already found some information. When x is negative 2, it's a 0. The function is 0. And when x is positive 2, our function is 0. So we actually already found those. But we can double check using our calculators, which is super handy. So we're going to go ahead and use our calculators. And again, make sure you're putting parentheses around the numerator here and parentheses around that denominator. So we have 2x squared minus 8 over the quantity x squared plus 2x minus 3. Got parentheses around the top and parentheses around the bottom. Very, very important. And then I can graph that. And it's important when you're looking at this, you can kind of see like how the graph moves, but it's flattening out here to the left and to the right. That's a horizontal asymptote right in between there. All right. You can also see we've got these vertical where our graph goes in opposite directions. There's a vertical asymptote there and another one here. So you can see a lot. All right, I'm going to use trace and type in -4. I get 4.8. I'm going to double check myself here. I'm going to type in -2, and I'm hoping it's going to spit out a 0. Sure enough, there it is right there. I'm going to type in 0, and I get 2.666. And I'm going to check 2 as well. And again, it tells me that there's a 0 there. And you can see this is a very different shaped graph. I have an L shape, but then I have a stretchy S shape here in the middle. And another sort of L shape on the other side. That's kind of a different sort of shape. So we have -4 up 4.8. 1, 2, 3, 4, almost to 5. And we get that L shape. -2, 0, and 0, 2.666. And that's sort of a stretchy S shape there. And then I have 2, 0, and that's my little L shape in the corner. All right, ladies and gentlemen, zeros come from the numerators. When there's x's upstairs, you'll have zeros. X-intercepts. Vertical asymptotes come from the denominator, and you can reduce those leaders to figure out your horizontal asymptote. And that is all she wrote. Do you have any questions for me? All right, you have another worksheet. So you can work on that, and it'll go in the orange bin when you're done.